So the Earth, Sun, and the Moon are actually working. We use them to work together to and have a number of things happen on Earth because of those three things working together. For example, all time in all societies is based on the rotation of the Sun and the Moon. Also, the daily rising and setting of the celestial objects of the Moon and the Sun is due to their rotating. So if you ever had to prove that the Earth rotates, you could use a variety, you could use two different ways. One would be the Coriolis effect, which a lot of you know what that is. One that you may not know, that I love seeing these at like space like centers where you can look at things, or physics centers, is called a Foucault pendulum. And this type of pendulum, I'm showing you this little video really quickly. Um, this pendulum basically swings in a constant direction, but as the Earth moves, it tends to look like it's shifting rotation, but it's actually the Earth moving. I love watching these pendulums just because it's so cool. And I'm a bit of a science nerd. I just like that kind of stuff. So the time period from noon on one day to noon of the next day is called a solar day. If you ever needed to prove that it takes 24 hours for Earth to rotate, you could do this by watching the apparent movement. So, what you feel like is the sun moving and the stars moving. Of course, we know it's us that's moving, but the apparent movement is what it looks like, to us here on Earth. And then, if you ever needed to prove that it takes a year for the Earth to revolve around the sun, you could look at the yearly cycles of the stars in the skies. So, as the Earth rotates around the sun appears to rise in the east and set in the west. The Earth actually spins on an imaginary line through the very top and the very bottom called its axis. And the Earth is tilted on the axis at a 23.5 degree tilt. And the Earth always travels around the sun in what is called the elliptical plane. So, the elliptical plane or elliptic plane is like if you stuck a flat piece of paper through the center here, you could cut through both of them, and the Earth will always stay on this exact, like if it was like a piece of paper, it would always stay exactly in that paper and not go, above it or below it. So, twice a year we have what's called the solstice, and the solstice, um there's one in the summer on June 21st. That is, for us in the northern hemisphere, the day of the year that we get more sun, more hours of sunlight than any other day of the year, and that's called our summer solstice. So that's the longest period of daylight for the whole year, is June 21st in the northern hemisphere. Our shortest day of the year, so what I call the darkest day of the year, is December 21st. It's 6 months later. So we have the least minutes of sunlight in the winter solstice. We also have periods where we have the most equal, like where the minutes of darkness and light are the closest they get all year. And these are called the equinoxes. We have the fall equinox and we have the spring equinox. And equinox, it sounds a lot like equinox, and all over the earth, that's where the sun is the most equal everywhere on Earth, not just in our northern hemisphere. Okay, so the phases of the moon, I want to move on and talk about this because it is really important. So the phases of the moon are these. When we are on Earth and the sun is hitting the moon from this direction, it's lighting up this backside of the moon that we cannot see. And because of that, the moon appears dark to us. And so we call that a new moon. I don't know why. I've always thought that's a weird word for a new moon. It doesn't, we don't see it at all. And then as it waxes, meaning it gets more and more light as it spins, we can only see a tiny little sliver of the light, this tiny little side of the light of the curve. We call that a waxing crescent. And then it starts to be halfway lit up to us, which is the first quarter. And then it gets the waxing gibbous, where it's like mostly lit up. And then it turns into a full moon. Then it starts going to the waning gibbous, the third quarter, and the waning crescent, meaning it's waning, it's about ready to go away to that new moon again. To go through all the phases of the moon is actually called a lunar month. So that's going to be important for you. Something that's just absolutely amazing about the sun, or I'm sorry, about the earth and the moon, is that they have the exact same rotation. This phenomenon that is so amazing to me, and scientists just think that it happened because of the gravitational pull and in its formation, but this is called a synchronous rotation, to have the exact same rotation. The next piece that's going to be really important for you out of this section is tides. When the moon actually pulls on our oceans. Like, the oceans are huge, the moon is huge. So the moon really pulls, and water can move anyways, and makes these tides. And it's actually the gravity like pulling that water up. And the moon actually has a larger pull on our water than the sun does. Not, the sun is much bigger, but it's so far away that the moon actually, even though it's smaller, has a better pull because of how close it is. But when the sun and the moon are in like alignment, and they're both pulling on our oceans, you get big tides, and those are called spring tides. Those are the tides that everyone wants to surf, and they have different challenges planned around these bigger tides. At different points in the year, if you live near a body of water, you can actually have smaller tides. So like the low tide and high tide are pretty close together, and that's because the moon and the sun are actually like in this perpendicular formation from each other, and so they're pulling in different directions. The moon is maybe pulling up, and the sun is pulling to the side, so they kind of end up canceling out each other a little bit, and this is called a neap tide. These are just not as strong of tides. We also have these amazing phenomena that people love called eclipses. It's so much fun to see an amazing eclipse. And a solar eclipse is when the moon is in between us and the sun, and the moon is actually blocking the light in this tiny little area called an umbra. So if you look at it, only a tiny little tiny little space can actually see the full eclipse. And then to the sides, there's a lot of people that can see the partial eclipse called the penumbra. And so this is a solar eclipse formation. Different than that is the lunar eclipse formation. And in this formation, the earth is actually blocking the light from the sun. And because of that, the moon can appear very like eerie blood red. It can be really cool, but we're basically blocking most of the light from the sun, and so we are shadowing the moon.